Hello everyone, back again. What we have is this V block. I'm going to have to grind this. This goes on our spin fixture, and in order to make that boring bar for Keith Rucker, I'm going to have to get this ground up. What I had, I made this originally out of DC 53, and when we send out the blocks the squaring blocks, that was DC 53, so I just sent all this stuff out together for heat treat, and that way we can share the cost with all that. But anyhow, this was ground kind of rough in, not just super precision, but plenty good enough for what I was using it for. But I just wanted to show you that the squareness checker also, it doubles real nice just as a indicator stand, so I can come across there and see how much distortion I might have got out of heat treat if something really warped and went way out. So this surface right here after heat treat is within a thou, and I don't have a fine adjust on this, and the ones that we'll be making here in the near future, I'll be making a fine adjust. But the way I do it now is I just bury the indicator out, tighten it down, and then I can come in, and then I can just kind of like that, and you can see it falls off, comes in, and so I got to just horse around with it a little bit, and then I can get it to indicate in. With the fine adjust, it'd be a lot nicer for that, but having a Noga base and a fine adjust on that will come in handy just as a nice indicator stand for checking your work in this manner. And so anyhow, what we're going to have to do, we're going to grind this out. And generally, when you grind, you want to pick your the area that's got the most area, this surface right here. And what I'll do is I'll grind everything to that. So I'll set this down on the magnet first, and then I'll just clean this up, and then I'll flip it over here. And this is where I got to be careful because I have very little holding there. So I got to be careful when I grind because it's going to have a tendency to knock over. This would be one of the rare occasions I might set a block up behind it to keep it from tipping. So we'll see how well it holds on the magnet. I'll just get a feel for it. But what I'm going to do is I'm going to get this surface and this surface. I'm going to get those two surfaces flat and parallel, and then I'm going to grind everything to that, square it up. We'll take some cuts on the V's, and what we're going to do after we take some stock off the V and we get the V in real good, I will be putting a test bar in here, and I'll be measuring the squareness. And what I'll do at that point, I will grind outside the block again square to my V with the test part in there, because I find that's a lot easier than trying to hit this V just so super close, because everything compounded when you grind on 45 and 45 like this. It's hard to get it closer in a couple tenths, 10,000ths of an inch. But if I get my surfaces real good and then true the block up to the V itself, I can hit it in under a tenth of a thousandth without too much issues. What I did is I took this to our deburring wheel, and I deburred the edges already before I started. And I like to do that because when I grind, if I don't do it, I leave sharp edges, and then I got to come with the deburring wheel, and then a lot of times you can see it feather into it, and this way it gives a nice cleaner edge. So we'll get the three-phase converter fired up and get the grinder going, and then we'll get back with you, and we'll start the first two surfaces. When we was grinding the squaring blocks, a few of the comments, people wanted to know what wheel I finished the block up with. I actually didn't change the wheel. I used this wheel. That's what I have on there right now, but this is 8BP46H800VOS. And what it is, it's a ceramic mix, and maybe we can take some of our pictures from our archives, and then Kat can show you a blow-up of that, because we have it on some of our other tapes. But it's a porous construction, and you can see the little grayish blue, and then you got the purple in there, but the grayish blue is the ceramic, and then the purplish, that's your aluminum oxide. So it's a ceramic aluminum oxide mix, and the reason I went with that, and actually here's a brand new one, that's the one I should have started with, but you can see it is quite porous, and Kathy, well, we got some archives that she'll go into and pull up some good pictures on that. But anyways, it works really good for roughing. It works good for finishing if you dress it often, and that's the key to get a nice finish on it, which I got on that block. But what you guys haven't seen on the camera was that I did dress that wheel quite often, and this would have been the wheel I would have wanted to finish with, and this is a RAA 46 H800 VOS. So there's no ceramic in here, but it's aluminum oxide. It's the ruby aluminum oxide, and it's got the porous construction on it too. And what this here grinds a little bit freer with a little less heat, a lot more forgiving, and the finish is just a little bit better. So the problem is that these wheels, the diameters are getting down quite small right now. Kathy's going to get me a scale. They started out at 8 inches, and when I'm doing the grinding like now, they're about 6 inch. When I'm grinding stuff, I like the 8-inch wheel, and people will talk about, well, your surface footage is off a little bit there. I'm not concerned about that, but if I have, what I'm looking at is the circumference on an 8-inch wheel is quite a bit bigger on the circumference. That means I have a lot more cutting edges, and so I have my best results, my most accurate work, best finishes using an 8-inch wheel, and using, again, with all the other variables, a good dress, good sharp diamond, using a cluster diamond, a lot of variables involved in there, using it with coolant. So anyhow, I got the ceramic wheel on here because it did cut, and it worked real nice for the cube. I'm going to just go ahead and keep it on here, and we'll get this where we're grinding. I have this on about half magnet right now. I'm just touched off, and I'm just going to take a light cut. And because this was pre-ground, and I was using it in a soft state before we sent it out for heat treat, it should just need just a little tiny bit of cleaning up. It shouldn't be that hard or that much labor in getting this thing really good. So now I'm doing my 2/10 pass right here. Now we're just going to try for about a 50 millionths, and we'll do our cut, slowing our traverse down on the Y, just like we did on the blocks, squaring blocks we just did. And then we'll just take a couple blank passes. That way we can keep that nice and smooth, the flatness, everything will be good. We will actually be using the squaring cube in order to grind this block square here. The squaring blocks will really come in handy, is when you get a shape like this, if you grind it right, you can probably do a lot of the work in a toolmaker's vise. But you get these oddball shapes, just kind of hold them in, hard to get them held in there real nice and square. Putting shapes like this on a cube, it's a piece of cake. And one reason I'm grinding the top here and the bottom is because I got a slot on this side, I got a slot on this side where I can put a 1/4-20 screw with the washer on and hold it when I want to do, yeah, I'm not sure if I'm going to do my V's there. I got another idea. I'll have to look. I might not do the V part on the square and cube. I may do that in one of my special made V blocks just to show you how nice those work for doing this type of work. With the light magnet, this spins too easy, and as I'm grinding, it's going to be wanting to shift on me, especially that hit out here with the leverage point is going to be wanting to spin. That's going to make an unsafe situation. There's a couple things I can do. I can take something like this. Let me first turn the residual magnet on so it doesn't slam down, but even the residual's got some in there yet. I can put something like this, or I can get something wider, but this happens to be just the right height. I can put that in there and help back it. And this is called blocking in, and I'll do it in some cases, and this is the case where I can go this way, or what I would probably prefer to do is just go ahead and turn the magnet on full magnet, because I got enough length over here. Already got this surface pretty flat. There's very little chance I'm going to have any distortion from the full magnet on here. And I can come over here, and I got to put a lot of pressure to turn that, way more pressure than what it's going to take to grind. So I got this on full mag now. And I'm just going to come across with the blank pass where I left off, just because it is setting up kind of funny over here. And if there's any high corner or anything, I just want to make sure that I can knock that off before. And we didn't even touch. So when you do grind something like this, you don't want to take real heavy cuts anyhow. I'm only going to take about 5/10. Because you take a heavy cut, it hits on this backside and pushes down. You don't want this part releasing from the magnet. This is the kind of stuff that you just got to develop a feel for from experience. It can be dangerous. If that would kick over, it would catch in that wheel. It can send that off, and I mean, if it hits just right, it can send it off with a lot of velocity, and then you're going to have wheels flying. So you got to be careful. You know, if you don't have the experience to know what you can get away with, and if you're using a fine grit wheel, you know, if you're using an 80, 100 grit wheel on something like this, you're asking for trouble. Because what's going to happen is that's going to heat up real easy. And as it heats up, it's going to pull into the wheel. And when it pulls into the wheel, it's going to grab harder, and you will be throwing that part off. So, one other reason I like my 46 grit wheels. I can get a better finish than almost all the 60 grit wheels I use. And I got a much freer cut. Here we got 8/10 total. And now we're just going to try just to get about 50 millionths to a tenth. We'll do our finish. We'll get that all cleaned off, and then we'll go to the granite table and see what we have. This is a Brown & Sharp. It's a 1/10,000th of an inch indicator, but it's got a little half mark in between the 10th reading, so they'll call them a 50 millionths indicator. And you can see that is riding really nice on that surface. And so now we'll flip it over and we'll look and see what we got on this surface now. And you can see that needle's not even moving. Nice, smooth. And the finish, it just came out awesome. I don't know if you can, I'm going to just try to roll that around, Kat, so that you can, are you focused on it? It's hard to catch that finish in the camera. A lot of times that finish looks a lot better in the camera than it really is, but this is a super finish. I'm real happy with it. And so now we have this surface and this surface flat and parallel with each other, well beyond what I'm going to need. Easy within a 50 millionth. And so what we're going to do now, I'm going to get my squaring block, the one made out of A2, and I'm going to set this up. And what I'm going to do is I'm going to try to set this up and so that I can grind this surface, and I'm going to grind this surface. Even though this surface really is going to be a non-functional, I need it for a reference. And so I just like to get the cleanups all around. Now I could grind this surface and this surface. I can come back and try to grind this surface from here, but I'd rather have the longer surface cleaned up off my block because I got a good tight hold. And then I can set this down on the magnet and I can clean this surface, and that way I can get that surface and this surface parallel. And again, this would be, not that it needs to be ground, but I can get it referenced out and get it good here, because this surface I want it running good and true to the block, because this block, even though it is sitting on my spin fixture for usage, I'll be able to use this as a standalone block too. I'll be able to use it like this. I'll be able to mount it on my cube this way. I'll be able to set it down on something for a reference on that side. So I want all these surfaces. I'll even grind this bottom surface over here. I want all that stuff flat, parallel, and square, really good. Okay, here we're going to use the squaring block. I'm going to use the hole, and it works out just about perfect. What I want to have this so that it's off the edge, so I can grind that without touching that. And then I want this off the edge, and so I can put this one screw in here and I can get it good. Later on we'll be breaking out our little finger clamps and using those, but for this I should be able to use the one screw. One important thing I got to tell you is when you use these squaring blocks, because they are 6062 Rockwell, and even though they're DC53 and they're much tougher than A2 or D2, you still want to take your screw, and you can see the gap that I have over here. I want to have at least 1/4 of an inch thread engagement in there. If you have only 1 or 2 threads that are engaged, if you just go 1 or 2 threads and you engage and then you try to put a lot of force on there, I've seen people take their cubes and do this, and I'd see them, they would crack an entire section out of that and pretty much destroy that area of their cube. So for those of you who are buying these, just remember, get at least 1/4 inch of thread engagement. I tap these down so that you got almost an inch, pretty close to an inch of thread, so you can get 1/4 inch down and still have over a 1/2 inch adjustment if you're using your finger clamps. So this is just a key point you got to remember. And what I'm going to do is I'm going to get that just kind of snugged down, and I'm going to indicate it in here in a minute. But what I like to do is I like to take this square, it's a 45-90 degree square, and I can come over here and I can just get that real close to being square just by being on top of here, and then I can get it pulled out. Let's see. So I can get it real close that way, snug it up. Now that just happened kind of nice, real quick. It usually doesn't happen that good, but I think Uncle Murphy must have went on vacation, hopefully here. So anyways, what we're going to do, we're going to see how square that got that just by using that 45. And you can look at it, it's less than a tenth out that way. We're 2/10 low. And over here, we're just about half a tenth high. So I'm just going to take this a little, and I mean I could actually grind it in from there, but this is how you would adjust it on your block. So now we're about a 1/10 low, and we're about we're within a tenth. Let's see what we got here. Oh, that looks less than a tenth. Now what I'm going to do is I'm going to snug that up real good. Other thing, you don't have to really reef. If you really reef on your work, you got to get it in your head that this steel is like rubber. You squeeze in it and it's going to deflect. I want this tight enough that it's not going to move, but I don't want it so tight that I'm deflecting the steel. When you start getting into you know, a few tenths tolerance and stuff, just the amount of pressure you tighten there can really affect things. And so you just got to keep that in mind. Now a piece of rubber, it obviously will smash in, but the steel, it does move. Even though you can't see it with the naked eye, it will move on you, and it will distort. And so then you grind it when it's when it's distorted, you loosen your screw up. Well, now you're distorted in the grind itself. And that stayed real good. We're easy within a tenth. And if I'm distorting that piece, once I grind it here and I loosen the screw and this surface is distorted, when I grind this other side without screw pressure on the magnet, I'll be able to tell the difference from one side to the other, whether I distorted it or not. So we'll set this up. In this case, I'm not going to use coolant and fill these holes up, so I'm going to take it real easy. That's one of the other reasons I got it within a tenth. I know that I'm going to end up with a bowl, but I'm going to have a high side here and a high side here, so when I flip it over on the magnet, I can turn the coolant on, I can grind that nice and flat, and then I can flip it back over and just take that 50 millionth bowl or whatever I may get out of there. So that's going to be a whole lot better than spending a lot of time getting that coolant out of here, out of these holes. Okay, what I've done is I took a fresh dress on this wheel because I know I'm going to dry grind. And this is where I would definitely prefer the other wheel that doesn't have the ceramic in. But we're going to make this work. Again, like I say, if I can get my high points on both ends, it will automatically come out square and flat on the other side. And then when I put it on the magnet, I can grind it and get it this side flat to that side, flip it over, and I can grind whatever slight bow I may have in there. So what I'm doing right now, it's just going to be a lot less work than flooding this with coolant, cleaning all these holes out and blowing that, because they always leak and they get in the way, and it can save you a lot of time on a project like this. So I just touched off. A lot of times when I dry climb like this, I won't even do a full cleanup. I'll just get where I know the points of contact that I want to clean up. I'll get them cleaned up, flip it over, grind a full contact, then flip it over and grind that, and it comes out good. So This is just another method that I use that saves me a lot of time when I'm grinding. And so right now we got a nice clean up in this area. We're touching a little bit here, touching a little bit there, and a little bit shy in that area. So we're just going to try to take about another 1/10 off. And see, with that sparks right there, I know I'm throwing some heat in there. But we do have a full cleanup. What we'll do is we'll throw this back on the granite when I'm done, and we'll throw the amp on, and we'll see if we can measure a dip in the middle. And it doesn't take much more than a few degrees difference than your room temperature over here to affect the reading. But right now we got pretty much 100% cleanup. What I'm doing is I'm feeling this. I'm comparing it with my block. I can feel just a few degrees different in there, or a noticeable, I should say, but it's not like it's really hot. So what I'll do a lot of times when I got that, and I know there's more heat in there than I want, what I'll do is I'll wind over here, because this wheel's turning this way, it's throwing down cold air. So I'll wind this over and I'll let that cool air just hit on that and bring that down a little bit, because from here on out I'm going to try to take less than 50 millionths at a pass on there just to smooth it out a little bit. If you dry grind and you use a few little tricks like this, you'll be surprised how good you can get that. And sometimes you can get it just spot on, but you have to work at it. If you're wanting to get this less than a 1/10,000th of an inch flat, and then it's really hard to do without cooling. What I'm going to do is I'm just going to come across now. I'll let it cool a little bit, and I want to see if I can see any sparks, and I can see just a few little sparks. And just shoot for about 50 millionths, and the indicator, the digital did go down 50, but it doesn't look like I'm seeing anything here. And I can see it's high over here. I'm not hardly touching in the back. I can hear it. I can't see sparks. Over here, I can see the sparks. So I'm going to feed down at this side. Is where I want to feed, and come back the other way. And now that looks pretty good and even all the way across, so I'm just going to do a blank pass it a few times. Yeah, what we're going to do now, we're going to turn this block at 90 degrees, because if everything worked out real good, because this block is square and this is flat here, we just ground this surface off this block, so this surface should be as square as what this block is. And now when we turn it up at 90 degrees, we can grind this surface over here that we'll be working from as a reference surface, and that should make it square to this side, and it should make it square this way. So if everything works out right, we'll have this block, this back side, this side, and this side, and this front side will be all square and parallel with each other, with the extreme close tolerances here. Hopefully less than a 10,000th of an inch. Yeah, it's touched off pretty heavy, so we'll just take it easy. We probably touched off about 5/10,000ths of an inch. So you can see that was pretty square to begin with, but again, it was ground up real nice before heat treat even. We're using it in a soft state. It's actually been kind of nice to have it in a hardened state now. It's a little bit low on that side, so I'll link that up. With a little surface like this, way less chance of generating a lot of heat. Pull it over here, let the airflow come down, let that set for just a little bit. We'll take her to the granite and see how it looks. Okay, what I ended up doing is I ground and I checked it, and I didn't have the bow, but I had a steady taper on both sides, and I get that sometimes. And so Kathy had to go in the house for a little bit, and so I just set it back up on the grinder, and then I turned the block 90 degrees to work that out because I wanted to get flat. And so I'm sorry I didn't get that on camera. That's why I'm telling you about it now. Before we're grinding that way, and then I ground this way, so we should see a bow this way, but it actually come out pretty good. And I don't know, Kathy, can you get in here and see these little marks? When you're dry grinding, it is hard to get that perfect finish. You can see they look like just barely little tiny burn marks, but I mean, I'm not even taking 50 millionths off on a pass on that. And so the technique that I've used before, where you saw me painting on undiluted coolant, would probably make that finish pop. It would probably eliminate all that. If I have to do some more dry grinding, I think I'm going to try that just out of my own curiosity. But anyways, we'll get back over here. I got the amp set at the 50 millionths. And we'll get that adjusted down to 0. And you can see where it looks, just taking a guess, maybe 10 millionths. So with dry grinding, you can see we come out within 50 millionths. And what we'll do is I'll kick this up to each of these lines now. We're on the most sensitive. From here to here is 1/10,000th. So from here to here is 50 millionths. And from here to the next big mark is going to be 25 millionths. So it gets kind of hard. It wants to bounce around. We'll just see what it looks like. There, each of those lines represent 5 millionths. Right there we're probably close to 20 millionths high. If I set it there, so if I just stop, we're at 10 millionths high. If I stop, we're about almost 25. At about minus 10, minus 5. So we'll check this other side, and like I say, that is more than close enough than what I want, less than a 1/10,000th without a problem. Bring this back down to the 50 millionths. And we're back on the 50 millionth setting. Yeah, so it rides up there pretty darn good. It's showing that that side's really close. We'll kick over to the 5 millionths mark. Yeah, so you can see that's within easy 25 millionths on there. So we got a nice reference here. This should be now as square as what this block is in both directions. So within that 50 millionths, easy within a tenth. And so a lot of this work is done as far as getting my reference sides. I got this side as a reference, I got this side as a reference, this side as a reference. So now I don't even need my cube. I can just set it down on that side, dust this side off. I can set it down on this side, dust this side, and dust this side off. And once I get those dust off, then I'm going to set this up in my V-block, and I'm going to grab it in a minute. Some of the older subscribers will recognize this. Again, it's one of my favorite tools right here. But I got a nice, very high precision V-block. I got nice counterbore holes in here, counterbore holes in here. Got holes in the side and some tap toes. So this thing comes in handy. I can mount it to just about anything I want that's in my own tools. I can mount it to this cube, make a big gooseneck out of it. So what's going to be nice over here, once I get both sides ground, I get this bottom ground, I'll be able to set this up in here, and then now I'm going to be able to grind this surface. And to get that nice and central, all I have to do is flip it around and grind that surface. So now I got my 45-degree angle established, and I'll have my centralness established. And it'll work out really nice. And we probably won't get to that point in this video. What I'll probably do off camera, I'll go ahead and get this squared up over there, and then the next video will actually show setting up in the V block over here to grind this V, and it really makes short work out of it. Another way that you could grind that V is if you wanted to mount it to this cube. I could mount it and hang it out like that, and then I can grind a V, and then I can flip it over 90 degrees and grind the V. And then it's going to be hard to hold the centralness on there, but I can get the angle established very good and the squareness very good on here. By grinding in the V block, not only am I going to get the angle good and the squareness good, I'm also going to get the centralness of the V to the sides here really good. It'll be a lot easier doing it in the V block than what we're going to be able to do on this block. So this would be part one of this video. We got the preliminary stuff set. We got 3 nice reference sides that we'll end up grinding the rest of the block to. And we'll do that in a part 2 of the video.